Okay, here's your XYZ coordinate system, and here's a circle in the XY plane. Note that the circle is tangent to a vector in the X direction here and here, so it's got to be tangent to lines parallel to the X-axis, right? It's got to be tangent to the Y here. Yeah, I kind of got it right. Still not a very good circle, but you know, it's maybe a little squarish. But you get the idea, okay? And I could do a little better if I really tried, but why show off? Could do a whole lot better. And then, you know, the thing, you also would have a sphere or circle in the XZ plane, okay? So it's like you have a circle here. Kind of like two perpendicular rings, right? And from there, it gets really kind of hard to draw it. You could also have auxiliary XY axes here and here. So, you know, let's distinguish this by a different color. Okay, so we have an auxiliary XY axis here, okay? And it comes out to here on this ring, okay, and back to here on that ring. And obviously, yeah, I don't have good symmetry here, but should, okay? And it comes out to equal distances here and here, so it's like you got a circle here, and an auxiliary axis would give you a circle about here and here and here, another circle here. But parts of these circles are hidden, so you kind of erase the hidden parts, okay? And you end up, and you go down here and you kind of do it, and then you figure out what's hidden and what isn't. And if you do that carefully, you actually get a reasonably decent representation of a sphere. Now, right now, I'm just going to slop it down. It's kind of like this, kind of like this, kind of like this, kind of here, here, okay? So, you know, doesn't look much like a sphere, and I haven't bothered with the lower half, okay? But I guess I could. You could come down here and here, okay? So that looks just like the Earth, doesn't it? You see where it's evolving.
Maybe a map from about 400 years ago.
Well, yeah, I mean, you know, those guys were pretty good. You know, you look at those maps, yeah, they didn't get everything exactly where it ought to be, but you can at least tell what they were drawing in most cases. You know, like here be dragons. They know how to draw good dragons. Okay, so anyhow, that's kind of the way you would draw the sphere, but now we want to, you know, get a little serious here. And okay, here's our ith strip in the XY plane, right?
So basically you have an extra thick plane.
Again?
So basically you have an extra thick plane right there.
Well, you just have a strip, an infinite strip of the XY plane, right?
But it's infinitely high too, right?
No. Well, I mean, yeah, you can say, okay, in 3 space, this strip corresponds to the region between 2 parallel planes, vertical planes, right? Okay? We don't want to look at that. We don't want to even draw that because we're basing everything on this strip, as you'll see. Okay? Now the strip, you know, ends, oh, say about here, and it ends about here. Okay? It actually ends with the first cube and the last cube, okay, in the XY plane. Okay, so now we're confined just to this rectangular region of the XY plane, okay? Then what do? We partition this strip okay? And I'll go ahead and actually do that with a slightly different color. It's quite different color. Okay. So these are the boundaries of the y increments of the ith strip, right? Okay. Then we can take the ij region of the xy plane, and of course, you know, we can take the infinite region above and below this. Okay, but we can kind of draw a typical cross-section up here and then indicate that it just keeps on going. Does that halfway make sense? I'm going to make it, I'm going to darken it a little bit, but we've got this rectangular region, everything above and below. Well, we don't go all the way up and all the way down. We stop when we get to the sphere. So, you know, we stop, oh, say about here. Okay? And we stop when we get down here. Okay? And what we do is, I've still got colors left. Okay? Now I'm going to stay with this color. Okay? So we draw. Well, okay, I'm going to now fill this in. So you can kind of see what I've got here. And then I'm just going to indicate a stack of cubes, right? So here we have our stack of cubes. For the delta xi, delta yj region of the plane. Okay? Say 4, let's say above. Well, now say 4 because I don't want to write above and below. That's too much writing. Okay, so we see where this stack is. So the stack that I was kind of referring to and waving my hands over here looks kind of like this, right? Well, now we could do those stacks for every increment of the strip. Okay? So what we have here is this. So let's make this one purple. Okay? That's this. Okay, well, then we have similar cubes or stacks for the next region and the next region and so forth. So now we'll have another stack here. Right? Not very well drawn, but you get the idea. And of course this stack isn't quite as high as this one because we're moving out toward the edge of our sphere. Okay? The sphere's decreasing in height as we move in this direction from here. And we end up then with all these stacks, shouldn't have drawn as many, okay? Filling in the whole region above this strip, okay? I'm not going to draw the rest of it, but you understand now we just got stacks of cubes over here, okay? Now we have that for every strip. And of course the X is partitioned all the way out to the edge and all the way back, right? So we have strips going from here to there. So we've basically approximated the region within the sphere by all these little volume increments. Okay? Very important picture.